Hi friends! Welcome to math video number 12. Today we're going to be learning all about SOL 4.2a, b, and c. It's all about comparing and ordering fractions and mixed numbers, equivalent fractions, and how a fraction is really a division statement. Lots of good stuff. In order to do that, we're going to go on over to our friends at Math Antics. These fellas are so good at creating videos that visually demonstrate these math problems. So I think you'll really like it. They're going to start by reviewing fractions, probably some things that you might already know, but we're going to be laying a groundwork for the more difficult concepts to follow. So hang with me, and I hope you enjoy.
If you've been learning math for a while, then you probably already know a thing or two about fractions. And if you've ever had to, break a cookie in half to share with a friend, well, then you've used fractions in real life. Oh, well, thank you. That's because fractions are used to represent smaller pieces or parts of things. When you're first learning about fractions, it can help to draw pictures to see how they work. So let's start by drawing a circle. Now this circle represents what we call a hole. Now, not the kind of hole you can fall into, more like a whole cookie or a whole pizza. Now, if we divide that circle or whole amount into 4 parts, then we call each of those parts a fraction of the original whole circle. Because this is math and not art, we can't just keep on drawing pictures. We need to learn how to write out fractions using the language of math. Yep, you guessed it. That means using numbers. Unlike a regular number, to write a fraction you need 2 numbers. One number on top, one number on bottom, and a line between them. I'll explain exactly what the line's for later in the video. But for now, let's figure out what those 2 numbers mean. Remember, fractions are used to represent parts of something. And the number on the bottom tells us how many parts that something is divided into. The number on top tells us how many of those parts we have. For example, let's write a fraction for our drawing here. I divided the circle into 4 parts, right? So the number on the bottom will be 4. And I still have all 4 of those parts, so the number on top will also be 4. I have 4 out of 4 parts. That means I still have a whole circle. But what if somebody came by and took away 1 part from the circle? Well, the circle's still divided into 4 parts, so the bottom number would still be 4. But I only have 3 of those parts left. So that means the top number will change to 3. So I have 3 over 4, or 3/4 of a circle. Make sense so far? Good. Let's try another example. Let's say that I divide a rectangle up into 8 parts, and I give you 3 of those parts. Since the total number of parts is 8, the bottom number will be 8. And since you have 3 of those parts, the top number will be 3. So the fraction I'm giving you is 3 over 8, or 3/8 of the rectangle. No need to think. Oh, and it's important to remember that for fractions to work right, the parts that you divide the whole up into have to be equal. We can't take a candy bar and say, well, I'm going to divide it into 2 parts, so this is your half, and here's my half. Let's look at a few more examples so you can really see the pattern of how fractions can represent parts of objects. This rectangle is divided up into 3 equal parts, and 2 of them are shaded red. So 2 over 3, or 2/3 of the rectangle, is shaded red. The circle is divided into 12 equal parts, and 7 of those parts are shaded green. So 7 over 12, or 7/12 of the circle, is shaded green. The hexagon is divided into 6 equal parts, and 5 of those parts are shaded blue. So 5 over 6, or 5/6 of the hexagon, is shaded blue. All right, so you can see how fractions can be used to represent parts of objects like circles and rectangles, but fractions can be used for more than that. They can be used to represent parts of, anything, like pets, for example. Let's say you have 7 pets, 4 dogs, 2 cats, and a big fat hamster. Well, that means that 4 over 7, or 4/7 of your pets are dogs, and 2 over 7, or 2/7 of your pets are cats, and 1 over 7, or 1/7 of your pets are hamsters. It also means that your house probably smells like a pet store. Okay, so fractions can be used to represent anything from parts of a circle to kitty cats. But did you know that fractions can also be used to represent things you can't even see? Well, like a test score, for example. Let's say you take a math test and there's 20 questions on the test, and you get 17 of those questions right. That means that you got 17 over 20, or 17/20ths of the questions right. All right, so that's the basic idea of how fractions can be used to represent parts of things. But there's a lot more to fractions than that. In the next section, we're going to be looking at some of the other things we can do with fractions. But before that, let's review. Fractions are used to represent parts of a whole. Fractions are written in the form of a top number over a bottom number with a line between them. The bottom number represents how many parts the whole is divided into, and the top number represents how many of those parts you have. And finally, the parts that a whole is divided up into must be equal for fractions to work right. To really understand how fractions are used to represent parts of things, be sure to do the exercises. And I'll see you in section 2.
Learn more at mathantics.com.
Now that we know how to use fractions to represent parts of a whole, there's a few different things we can do with them. First of all, we can compare fractions. Comparing fractions means checking to see if one fraction is greater than, less than, or equal to another fraction. That's pretty easy if we think of fractions as parts of objects and draw pictures to help us see what we have. Here's an example. Which of these fractions is greater, 3/8 or 5/8? To answer that question, let's start by drawing two rectangles and divide them into 8 equal parts. Since the rectangles are divided into 8 parts, each of those parts is called an eighth. Now, let's shade 3 parts of the first rectangle, or 3/8, and 5 parts of the second rectangle, or 5/8. Our picture makes comparing these fractions easy. You can see that 5/8 is greater than 3/8 because more of that rectangle is shaded. Okay, now let's try one that's a little harder. Which of these fractions is greater, 3/4 or 4/5? Well, let's start again with 2 rectangles, but this time we need to divide them up differently because the fractions we're comparing have different bottom numbers. The first rectangle will be divided into 4 equal parts, and we'll shade 3 of them to show 3/4. The second rectangle will be divided into 5 equal parts, and we'll shade 4 of them to represent 4/5. Now to compare, all we have to do is see which rectangle is shaded in the most, and that tells us that 4/5 is greater than 3/4. There, that wasn't so hard after all. All right, let's try one more example. Let's compare the fractions 1/2 and 2/4. Again, we start by drawing rectangles and dividing them up into parts. 2 on this one and 4 on this one. Next, we shade the parts of the rectangle according to our top numbers. 1 on this one and 2 on this one. Now, all we have to do is compare. Well, what do you know? The same amount of each rectangle is shaded. That means these two fractions are equal. It might seem strange that 2 fractions can have totally different numbers and still represent the same amount, but they can. Fractions like that are called equivalent fractions. Equivalent fractions have different top and bottom numbers, but are equal in value. We'll learn more about equivalent fractions later in this video, but for now, let's find out what else we can do with fractions. Another thing we can do with fractions is add them together. Any 2 fractions can be added. But for now, we're only going to add fractions if they have the same bottom numbers, because those fractions are much easier to add. Like these 2 fractions, 1/4 and 2/4. Let's add them together. Again, we can use drawings to help us solve this problem. Looking at the rectangles for these 2 fractions, we can add them visually just by rearranging the parts. Because all of the parts are fourths, our answer will also be fourths. We can just take this 1/4 from over here and combine it with these 2/4, and ta-da, 3/4. So 1/4 plus 2/4 equals 3/4. Let's try another one. Let's add 3/8 to 5/8. Now we can use any shape we want, so I'm going to use a circle this time. So we have 3 out of 8 here and 5 out of 8 here. Just like our last problem, we can add these by combining the parts. So let's put these 3 over here with these 5. And well, what do you know? That fills up all 8 sections. So 3/8 plus 5/8 equals 8/8, or 1 whole circle. In those examples, you might have noticed a pattern. The bottom number of our answer was always the same as the bottom numbers of the fractions we were adding. And the top number of our answer was just the sum of the top numbers of those fractions. Well, that's how it works. That's the procedure or set of steps for adding fractions that have the same bottom numbers. That's important because if you can remember that procedure, then you won't need to use drawings to help you add fractions. And that's a really good thing, because what if you had to add these two fractions together? 1500ths and 1000ths. It would be way too much work to draw rectangles and divide them up into 100 parts. Fortunately, since we know the procedure for adding fractions, we can do it without the drawings. First, let's write out the problem. Now, because we're adding fractions, we know that the answer will also be a fraction. The bottom number of our answer will be the same as the bottom number of the fractions we're adding, 100. And the top number of our answer will just be the sum of our top numbers, 15 plus 10, which equals 25. So as you can see, adding fractions with the same bottom numbers is easy when you know the procedure. All of this brings up a really important point. When you're first learning about fractions, drawing pictures and imagining that fractions represent parts of cookies and candy bars can be really useful. And it can taste good too. Thinking of them that way can help you understand how simple fractions work, and it can even help you solve some basic math problems. But soon, you'll have to do harder math problems. And to solve those, you'll need to stop thinking about fractions as just parts of things and start thinking about them in a different way. And that's what we're going to be talking about in the next section. Before we move on, let's review what we've covered so far. We can draw pictures to show how fractions represent parts of a whole. Using drawings, we can compare fractions to see which one represents the greatest amount. If we compare two different fractions and find that they represent the same amount, then we call them equivalent fractions. We can also use drawings to help us do simple addition by combining the parts. By doing this, we learn that the procedure for adding fractions that have the same bottom number is to just add the top numbers and keep the same bottom number in our answer. Now, to make sure you understand how to compare and add fractions visually, be sure to do the exercises for this section.
Learn more at mathantics.com.
Okay, so far we've learned how fractions represent parts of things, and we've learned how to do some simple math with those parts. But if we want to really understand how fractions work, we need to start thinking about them in a new way. We need to learn what fractions really are. A fraction is just a number that's written like a division problem. You remember division, right? Where you take one number and divide it up by another number? And you might also remember that there's different ways to write a division problem. When you first learn about division, you usually see division problems written like this. Now that symbol in the middle just means divide this number by that number. Then you learn it's useful to write a division problem a different way, like this. Now that's still the same division problem. It just uses a different symbol to tell us to divide. So that's two different ways to write the same division problem. But wait, there's more. Now some of you who use computers a lot might have seen division written like this. Now that slash is just another way to write the division symbol. Now this one's interesting. Watch what happens when we rearrange it a little bit. Look familiar? Yep, it's a division problem that looks like a fraction. And that's just because a fraction really is a division problem, but we treat it like a number. The line between the top and bottom numbers is just another way of writing the division symbol. The top number is the number being divided up, and we call it the numerator. The bottom number is the number we're dividing by, and we call it the denominator. Now let's look at some of the common fractions that you're already familiar with and think of them as division problems. For example, 1/2, or 1/2, is really just 1 divided by 2. The fraction 2/3, or 2/3, really means 2 divided by 3. And the fraction 3/4, or 3/4, really means 3 divided by 4. Thinking about fractions like little division problems might seem strange to some of you, especially because these division problems show smaller numbers being divided by larger numbers. You may not have seen that before. You might not have even thought it was possible, but you can divide a smaller number by a bigger one. It just means that the answer you get is going to be smaller than 1. If the idea of dividing a smaller number by a bigger one seems confusing to you, don't worry. It's going to make a lot more sense in the next section when we learn about decimal numbers and how they relate to fractions. Let's review what we've learned so far. This section was short, but in it, we learned the most important thing there is to know about fractions. we learned that fractions are numbers that are written like division problems. The line between the top and bottom numbers is another form of the division symbol. That tells you to divide the top number by the bottom number. The top number is called the numerator, and the bottom number is called the denominator. It might be a new idea to you, but you can divide a smaller number by a bigger number. This was a really important concept we covered, so be sure to do the exercises before you move on.
Learn more at mathantics.com.
Now that you know that fractions are special numbers written like division problems, we're going to learn about some different types of fractions and where they're located on the number line. Because fractions are division problems, their value depends on the top and bottom numbers and the relationship between them. There are a few basic rules about that relationship that will help us estimate the value of a fraction and know about where it should be on the number line. The first rule is, if the top number of a fraction is 0, then the value of the fraction is always 0, no matter what the bottom number is. For example, 0 over 2 and 0 over 20,000 are both just 0. I like to call these fractions zero fractions, because they equal 0. Oh, and by the way, you can never have 0 as the bottom number of a fraction because you can't divide something into 0 parts, so don't even try it. The next rule is this. If the bottom number is bigger than the top number, then the value of the fraction will be greater than 0 but less than 1. That means it'll be somewhere in this section of the number line. Any fractions that have values in this range are called proper fractions because we can use these values to represent smaller parts of things. Our third rule is this. If the top number and bottom number are the same, then the value of the fraction is always just 1. So whether you have 1 over 1 or 5 over 5 or 100 over 100, the value is always just 1. I'm going to call this kind of fraction a whole fraction because its value represents one whole. Oh, and in case you're wondering, this rule doesn't apply to 0 over 0 because like I told you, having a 0 on the bottom of a fraction is a big no-no. Okay, our last rule is this. If the top number is greater than the bottom number, then the value of the fraction will be bigger than 1. That means it'll be somewhere in this section of the number line, which goes on forever. These are called improper fractions. Because even though they're written like regular fractions, since their value is greater than 1, they aren't really used to represent smaller parts of things. Alright, these rules show that we have 4 main types of fractions. We have zero fractions, proper fractions, whole fractions, and improper fractions. Knowing that these main types are in order from smallest to largest on the number line allows you to do some very simple comparisons between the 4 types of fractions. That's because we know that a zero fraction is always less than a proper fraction, and a proper fraction is always less than a whole fraction, and a whole fraction is always less than an improper fraction. Let's do a few comparisons to get the hang of it. Here we have 1 over 5 and 0 over 8. Since 1 over 5 is a proper fraction, and 0 over 8 is a zero fraction, 1 over 5 is greater than 0 over 8. Now let's do 3 over 8 and 2 over 2. 3 over 8 is a proper fraction, and 2 over 2 is a whole fraction. So that means that 3 over 8 is less than 2 over 2. Now what about 9 over 9 and 32 over 32? Now that's easy. Since they're both whole fractions, and whole fractions are always equal to 1, these fractions are equal. And finally, what about 1/2 and 5 over 4? Now we know that 1/2 is a proper fraction, but 5 over 4 is an improper fraction because its top number is bigger than its bottom number. So that means that 1/2 is less than 5 over 4. Now that we know that there are 4 basic types of fractions, and we've learned where they fit on the number line, let's learn more about how the relationship between the top and bottom numbers affects the value of a fraction. Let's go on a journey down our number line. Now we're going to start with this zero fraction, 0 over 20, and its value puts us here at 0 on the number line. To get moving, all we have to do is start changing the value of our fraction by increasing the top number. We're going to leave the bottom number the same the whole time though. Alright, let's go. We haven't gotten very far from 0 yet, and you might have noticed that the top number is still very small compared to the bottom number. But as the top number gets bigger, the value of our fraction is increasing. That tells us that if a fraction's top number is a lot smaller than its bottom number, then its value is going to be close to 0 in this part of the number line. Look at this. We're almost to 10 on top, and since 10 is half of 20, we're almost to 1/2 on the number line. It's pretty easy to figure out what half of something or double something is, and we can use that to help us compare fractions. Like we know that 9 over 20 is going to be really close to 1/2 on our number line. All right, so we've passed 1/2 now, and we're making our way to the number 1. Notice that our top number keeps increasing, and it's getting closer and closer to 20. In fact, when it reaches 20, we'll have arrived at 1 because 20 over 20 is a whole fraction. Knowing this can also help you estimate a fraction's value. Whenever you see a fraction with a top and bottom number that are almost the same, like 19 over 20, you know that the value is close to 1. There, we've passed 1 now, but we're still going, and our top number is now bigger than our bottom number, which means we have an improper fraction. You can see that the bigger the top number gets, the bigger the value of the fraction. And we could keep on going forever, but that might take all day. Okay, so our journey showed us some pretty useful regions of the number line. The region near 0, where the top number is much smaller than the bottom number. The region near 1/2, where the top number is about 1/2 of the bottom number. The region near 1, where the top number and bottom number are about the same. And the region past 1, where the top number is bigger than the bottom number, and it keeps on going forever. Knowing about these regions can sometimes help you quickly estimate the value of some fractions. For example, you can estimate that 1 over 16 is going to be pretty small, close to 0 on the number line. And you can estimate that 29 over 31 is going to be almost 1 because there's not much difference between the top and bottom numbers. And if you have the fraction 14 over 30, you can estimate that it'll be about 1/2, since 14 is close to 15 and 15 is half of 30. All right, that wraps up this section, and I hope it's helped you understand the different types of fractions and where they are on the number line. You'll understand even better if you do the exercises for this section. Good luck, and I'll see you next time.
Learn more at mathantics.com.
Okay, we've learned almost everything we need to know about the basics of fractions, but there's one more thing I want to tell you about, and that's mixed numbers. Sounds pretty exciting, doesn't it? To help you understand what mixed numbers are, let's look at the number line we used in the last section. Remember, there's two main kinds of fractions. Proper fractions, where the top number is smaller than the bottom number, and improper fractions, where the top number is bigger than the bottom number. Now, some of you might be wondering, why is the improper fractions region so much bigger than the proper fractions region? Why are there so many more improper fractions? The reason is that improper fractions are really a combination or a mixture of two different things. Lately, we've been focusing on the fractions on our number line, but don't forget, the number line can count whole numbers too. Let's say we want to use our number line like a ruler to measure how long something is. Let's start with something short like this rectangle here. Now this one is less than 1, so we can use a simple proper fraction like this. Now let's measure a rectangle that's a little longer. Well look, this one lines up exactly with 1. So that's easy. We don't even need a fraction for this one. Its length is just the number 1. And now let's measure a rectangle that's even longer. Now this one falls somewhere between the whole numbers 1 and 2. To write its length, we're going to need the number 1 plus a little bit more. So that means we're going to need a whole number and a fraction. To figure out what that fraction will be, notice that the space between the 0 and the 1 is the exact same length as the space between the 1 and the 2. That means if we divide the space between 1 and 2 into fractions, they'll be the same as the fractions between 0 and 1, the proper fractions. So this rectangle is 1/2 long, and this rectangle is 1½ long. It's like the proper fraction region is repeated between any two whole numbers. So while our number line counts whole numbers, in between each whole number, it also counts proper fractions. But wait a minute, if there's a whole bunch of proper fractions out here in between the whole numbers, then why have we been calling this the improper fraction region? Well, it's because improper fractions are formed by combining a whole number with a proper fraction, but the whole number part is hidden in the fraction. Starting at 0, you can count up through the proper fractions, but once you pass 1, they're called improper fractions because there's a whole number part hidden in the fraction. As always, a few examples will help this make sense. The improper fraction 3 over 2 is right here on the number line. That means that it's just the combination of the whole number 1 and the proper fraction 1/2. The improper fraction 4 over 3 is right here on the number line. That means that it's just the combination of the whole number 1 and the proper fraction 1/3. The improper fraction 9 over 4 would be right here on the number line. That means that it's just the combination of the whole number 2 and the proper fraction 1/4. Alright then, if an improper fraction is really just a combination of a whole number and a proper fraction, then why don't we write it like that? Well, we can. When we write an improper fraction as a combination of a whole number and a proper fraction, we call it a mixed number. A mixed number looks like this. The whole number part comes first, and then the fraction part comes right after it, a little bit smaller. And when you read a number like this, you say 1/2. You say the and because it really is like you're adding 1 to 1/2, but you don't have to show the plus sign. Now that we know that a mixed number is another way of writing an improper fraction, we're going to learn how to convert back and forth between those two forms. Let's start by learning the procedure for taking a mixed number and rewriting it as an improper fraction. Now there's a few different ways you can do it, but I'm just going to show you the quickest way. Here's the first improper fraction we're going to rewrite, 3/2. Now we know that our answer is going to be an improper fraction, so let's go ahead and write the fraction division line. The bottom number of our answer is easy. It's just the bottom number of the fraction from our mixed number, in this case 2. To get the answer's top number, we need to do 2 steps. First, we need to multiply the bottom number of the fraction, 2, by the whole number part, which is 3. So 2 times 3 gives us 6. Next, we take that 6 and add it to the top number of our fraction, which is 1. So 6 plus 1 equals 7, and that's the top number of our improper fraction. So 3/2 is the same as 7 over 2. Let's try one more to make sure you've got it. Here's 7 3/8. Now we know that our answer will be a fraction with 8 on the bottom. Now for the top, we take 8 and multiply it by 7, and that gives us 56. And we take that 56 and add it to 3, and that gives us 59. So 59 over 8 is the same as 7 3/8. That wasn't so hard, was it? Now that you know how to do that, let's try going the other way. Let's start with an improper fraction and rewrite it as a mixed number. Let's start by working our first example in reverse. Let's try to write 7 over 2 as a mixed number. Now to do this, we'll also need 2 steps. The first step is to see how many times the bottom number of our fraction will divide into the top number. And 2 goes into 7 3 times with a remainder of 1. So that tells us that the whole number part of our mixed number will be 3. The next step is to find out what the fraction part of our mixed number will be. The bottom number will be the same as the bottom number of our improper fraction, 2. And the top number will just be the remainder we got when we divided, 1. There, we changed the improper fraction, 7 over 2, back into the mixed number, 3/2. So we can see that it works both ways. Let's try one last example. Let's write 22 over 5 as a mixed number. Again, the first step is to see how many times the bottom number divides into the top number. In this case, 5 goes into 22 4 times with a remainder of 2. So we know that the whole number part of our answer will be 4. Now for the fraction part. The bottom number will be the same as the bottom number of our improper fraction, 5. And the top number will be our remainder, 2. So 22 over 5 is the same as 4 2/5. All right, so mixed numbers are really just another way of writing improper fractions. And it's a good idea to know how to convert them back and forth because it makes some math problems easier. And besides, your teacher's going to make you do it anyway. Let's take a minute to review what we covered. Improper fractions are really a combination of a whole number and a proper fraction. The whole number is sort of hidden in the fraction. If we write out the improper fraction as a whole number and a proper fraction, then we call it a mixed number because it's a mixture of 2 different kinds of numbers. We can convert back and forth between improper fractions and mixed numbers since they're just 2 different ways of writing the same value. The procedure to go from a mixed number to an improper fraction is to multiply the bottom number by the whole number and then add that result to the top number. That gives you the top number of the answer, and the bottom number is just the same as the first bottom number. To go from an improper fraction to a mixed number, we have to find out what whole number is hidden in the fraction by dividing. The answer of the division is the whole number part. The remainder of the division is the top number of the answer, while the bottom number is just the bottom number of the original fraction. Now, these procedures for converting mixed numbers can take a lot of practice, so be sure to do the exercises.
Learn more at mathantics.com.
All right. Now don't forget you're going to have some Study Island lessons assigned to you. There's 2 this week, so make sure you don't wait till the last minute to finish those. And if you want some extra practice with fractions, head on over to IXL.com, or you can even go back to mathantics.com, and they have a lot more videos on fractions. I think you'll really enjoy that. All right, well, you're off to great places. Today is your day. Your mountain is waiting, so get on your way. All right, have a great day, everybody. Bye-bye.